Hi everyone, this is Maureen and Matt from the Crust Conquer team. Today we're talking about our autonomous pizza making robot. Right now we're in final season and what we need is freshly made pizza available 24/7 to carry us through it. And so we're trying to make this solution available to everyone in the Boston area. So first we ask ourselves, what do we need to build? Our ideal solution comprises a mobile robot moving around the kitchen, a perception pipeline assessing pizza completion, an efficient ingredient spread routine so that the robot takes as much time as humans to make the pizza, and then also to not waste any ingredients.
To implement our system, we set up the following environment and technology. We used a KUKA EWA base and a mobile base station, a WSG gripper, a RGBD camera overlooking the pizza on the right, and a high-level state controller with multiple position modes. For our environment, we have 4 workstations using 2 tables, an oven, and a delivery shelf, 60 ingredients, and point contact simulation. For our perception system, we needed a way to determine how much of the pizza was covered with ingredients. First, we calculate the area of the pizza dough without the ingredients to set a baseline for our ingredient ratio, and this works with any arbitrary pizza size. Next, we use a clustering algorithm to filter the point cloud by ingredient color to select between mushrooms and tomatoes and different types of ingredients. Then we use a convex hull algorithm to calculate the area of each ingredient in the pizza. As we sum those ingredient areas and divide by the initial pizza area, we calculate our final ingredient ratio. That perceived ingredient ratio helps us decide whether we should keep spreading ingredients during the spreading process. To execute indefinite ingredient spreading moves and swap between different types of moves throughout the kitchen, we needed a high-level state machine and a planner implementation. Here you can see our existing state machine and our progress during this project. To make the state flow on this diagram was fairly straightforward, but implementing the state machine with on-the-fly controller parameter modification and decision logic in a custom leaf system was far more challenging than we expected.
So now onto our results. This video here shows a real-time example of our robot moving from the start pose, lifting a bowl of ingredients, moving to the pizza workstation, and then spreading the ingredients. In between ingredient spreads, the perception system evaluates pizza state and recommends another spread routine. Here you can see that it needed 2 spreads before it realized that the ratio on the pizza was good enough and to put the bowl back down. But along the way, we had quite our fair share of challenges. Here you can see that actually holding the bowl with the gripper is really hard, especially with the amount of ingredients that we have in the bowl, and getting the spread routine right is also very tricky. We also had our fair challenges regarding the state machine, as moving between different controller modes took a lot of trial and error. So this in fact brings the question of what did we build? So we did get a movable robot moving around the kitchen. We did get a perception pipeline assessing pizza completion, and we in fact did also get efficient ingredient spread routine. What we did not get is not wasting ingredients, and we did not in fact get our entire state machine through. However, we did build this controller with the idea of a long-term process, because our perception pipeline and our state machine are built to enable multiple pizza making, as well as different shapes of ingredients and doughs.
Next steps for our project would include implementing the full state machine shown here, generalizing our system to operate with more ingredients, and returning to hydroelastic contact to enable more realistic simulation. Thank you so much for watching.